Dr. Massey, do you have any pets?
So I don't have any full-time pets anymore, but my girlfriend does have a dog. So I do have a part-time dog, and he looks like this. He's little and he's a Maltese. And traditionally, I really like big dogs, but this guy's sweet and he's super annoying sometimes, but I still like him anyway because dogs are super cool. And yeah, that's pretty much it. He's smaller than a cat, but definitely still a dog. You can see he's got the dog ears, he's got dog nose and dog paw and all of that stuff. So, yeah, he's good.
Based on the current trend, when do you think that things will start to go back to normal?
Okay, so this is the big question. When do we go back to normal? And I would like to point out that in our lifetimes, things have never been normal. In the modern era, we have this kind of recipe for disaster, right? There's these three main factors that actually are going to produce pandemics like this. And we're going to have to make some adjustments. So, when do we go back to normal? I hope we don't go back to normal. I hope we um, rethink the way that our society works and solve this problem so pandemics don't happen. So, let's look at the mechanism really quickly. In the modern era, we've totally changed the way we interact with nature. We've totally changed the way we interact with animals. It's no longer just having a few chickens in your backyard or having a few cows out in the pasture or going deer hunting or something like that. Now we have these giant factory farms where we stuff a bunch of animals all in, um, crammed into a single building, and it's a place where viruses can replicate and viruses can mutate. We have these wild animal markets where we take bunch of exotic animals, bringing them in close contact with domesticated animals and people, and we basically test out, which viruses can jump from which animal and then into people, and it's quite risky. We're also going into natural areas like jungles, and people are eating exotic animals. People are eating even primates like chimpanzees, and by doing so, they're exposing themselves to new viruses. And so there's a variety of ways that we're actually creating new viruses and exposing ourselves to new viruses on a scale that has never existed on Earth. Then we also have a great travel infrastructure. So we have airplanes and people can travel all over the world basically whenever they want. And then we have a population explosion and a lot of urbanization. So we have a lot of cities now. So the mechanism is we create these viruses by the way we interact with animals, and then we can spread them all over the world on airplanes. And then once they get to other cities, they can spread all over the city because we live and work close to each other. Now, for my personal opinion, I love traveling. I don't like waiting in line for security, but I do really like being on an airplane. I've been to Europe 5 times, and it's great. I love experiencing new cultures and things like that. And I love working with people. I like working close with people, and I chose to be a teacher. So, and I also love cities. New York City's great. Chicago's great. And so I really hope we can preserve that way of life where we can travel freely, where we can see new people, meet new people, where we can work together in person. Those are just really great things to have. So what I would prefer and what I hope that we can come to is, looking at where these viruses actually originate and try to prevent future pandemics at that point, through new regulations and through new safety procedures for the way that we work with animals. Now, as far as the timeline, if we're looking at August, I don't think that the schools most likely will take all the teachers, all the students, everybody, and just cram them straight back into the school like we used to. I think it'll come in phases, and nobody knows what that looks like yet. But there'll be some kind of plan to keep people safe, and we'll kind of phase it in over time. What I've read is that the vaccine should take something like a year to produce. And then once we have a vaccine, that won't make it go away completely, not like overnight, but it'll pretty quickly make things go back to normal, so to speak, because this particular pandemic won't be quite as scary. But I think it'll take the world at least 10 years to really realize that we're putting ourselves at a serious risk by the way that we're living in the modern time. And hopefully, our leadership and the people that are in charge of the world will really take a look at these issues and try to prevent these new viruses to begin with. And then if there's no new viruses coming out, we don't have to be afraid anymore.
What is the largest celestial object ever discovered?
Okay, so to answer Aiden's question, we first need to do a little bit of astronomy terminology. So as a reminder, a solar system is a star or something like our sun with other objects like planets and comets and asteroids going around it, right? So they're orbiting the sun or a star. That's a solar system. When you have a bunch of solar systems together, that forms a galaxy. And many of the galaxies, including our own in the universe, can contain as many as 100 billion or even more stars, right? So galaxies are super huge. Now, the largest objects in the universe are clusters of galaxies. So we're talking about objects that have hundreds of billions of stars. And then now we're talking about clusters of those actual galaxies. Okay, so these galactic superclusters are the biggest thing in the universe. The very largest one has been estimated to be 10 billion light years across, which is actually larger than any physicist would have predicted. It breaks something called the cosmological principle. And the cosmological principle says that the universe is supposed to be more or less the same throughout. There shouldn't be, if you look at one part of the universe versus another part, things should be spaced out roughly equally. And when you actually look at some of these very, very large galactic superclusters, they occupy an insane amount of space and they contain just a ridiculous number of stars. Okay, so the very, very biggest one is called the Hercules Corona Borealis Great Wall. And the corona in the name doesn't have anything to do with coronavirus, so don't worry about that. But some of these objects are known as great walls because they're just these huge walls of galaxies, and that is the very largest one that we know of. Okay, cool stuff.
If air particles are held in with the gravitational fields of the core of the planet, and Jupiter is a gas planet, so all that gas is being held in by the gravitational field. So does that mean the core of Jupiter has a higher gravitational field than other planets, or does that probably mean it has a less gravitational pull because everything's more spread out?
So Jackson, first of all, I love your chair of wisdom. I think anytime you're in the rocker, it helps you think and helps you get your brain going. So a lot of people have had a lot of deep thoughts while rocking back and forth. So that's a really good idea. Your question is fantastic. So there's this issue of the nature of gravity and are the gas giants, is their gravity actually weaker because they're made of gas instead of being a solid rock? So maybe the gravitational force is lessened because of that. And you're onto something there. So basically the two main factors in gravity are how much stuff there is, and the more stuff something's made out of, the stronger the gravity. And the other factor is how close can you get to it. So if you can take, a lot of stuff and smash it into a tiny space so that you can get close to it, that's when you have the strongest gravitational field. So on the Earth, we have way less stuff than Jupiter and Saturn and any of the gas giants. They have way more stuff than the Earth. But the Earth is a solid rock, more or less. So you can get pretty close to it. And that means our gravity is pretty strong, especially considering the fact that the Earth is not made out of nearly as much stuff as the bigger planets. However, Jupiter is so much bigger that its gravity is quite a lot stronger. And there's one thing that really gives you a hint at this, and it's looking at what the two planets are made out of. So Earth, as I said, is rocky, but Jupiter is mostly made out of hydrogen and helium. And if you take hydrogen or helium and put them in the Earth's atmosphere, so if you take a helium balloon and just release it into the Earth's atmosphere, the Earth's gravity is actually so weak that the helium will escape. Earth's gravity is not strong enough to even hold helium into our planet. So every time we waste helium and pour it outside and things like that, it just disappears. It goes into outer space, and we can't actually recover it anymore. Our atmosphere does not contain any helium. All the helium we have to get it from underground, and it's quite rare. So when we run out, it's potentially going to be a serious problem. Side note, stars are also made mostly of hydrogen and helium, and if Jupiter was significantly larger, it would have actually probably turned into a sun. It would have been a star. And so we would have ended up with a binary solar system, and things would have been very, very different. The Earth either wouldn't have been here or would have been totally different. But Jupiter is basically like a star that wasn't big enough, right? But it's still huge, and its gravity is very strong, and it's strong enough to hold helium. So, all right.
My question is, why do carrots sometimes spark in the microwave?
Hi, Jude. Thanks for the question. So it's not just carrots that can create an arcing effect or sparks in the microwave. All kinds of veggies can do this, and it's because they contain minerals. If you've ever accidentally placed some foil or metallic silverware into the microwave, you know that's very dangerous. It can create fires, it can permanently damage your microwave oven. I do not recommend putting anything metal in there. But some of the veggies that we eat, leafy greens, carrots, stuff like that, they contain minerals. Sometimes it's just minerals. There's a little bit of soil or dirt left on the veggies, and sometimes the minerals are actually part of the vegetable itself. And so what those minerals do is they create variations in the electric field inside the microwave. And when you have a variation in the field, you can get the arc, because if one part of the electric field or if one object is different than the other, that creates something called a potential difference. And it's very similar to on a battery. So if you have the negative part of the battery and the positive part of the battery and you connect them together, you can see that kind of arcing or spark effect. And in a way, I mean, vegetables aren't exactly batteries, but there's some similarities there. And you might have noticed there's like people make potato clocks, and I think you can do this with lemons and things like that, where you can get a potential difference. And the microwave is just really good at helping us discover those potential differences because it has a bit more energy, and you can see those sparks, stuff like that. So good question. Thanks.